Ever imagine a robot that could follow your voice commands to navigate a real-world space, like finding a specific room in a building or avoiding obstacles as you describe the path? That's the heart of vision and language navigation, VLN, a field where AI learns to understand and act on human language in physical environments. But here's the catch. Real-world spaces are chaotic, and keeping up with continuous video streams while interpreting instructions is a massive challenge. Today, we're exploring a game-changing approach called StreamVLN, a system that's making AI agents smarter, faster, and more efficient at navigating complex spaces. Let's break down how it works, why it's a big deal, and what it means for the future of AI. So why is this hard? Imagine giving a robot step-by-step directions. Turn left, go straight, then open the door. The robot has to process real-time video of its surroundings, understand the language, and decide what to do right now. But traditional systems struggle. They either forget important details from earlier steps or get bogged down by too much data, slowing things down. It's like trying to hold a conversation while juggling 100 balls. Eventually, something drops. Enter StreamVLN. It solves this with a clever trick, a fast-slow teamwork. Think of it like a two-person relay race. The fast part is all about responsiveness. It uses a sliding window to keep track of the most recent dialogue, like a chat history that only holds the last few messages. This lets the AI react instantly, without getting confused by old info. But here's the slow part, it's about memory. Over time, the AI needs to remember important visual details from earlier steps. But storing everything would use way too much memory. So StreamVLN uses a smart pruning strategy. It analyzes the video stream and discards redundant details, like deleting old emails you'll never read again. But it keeps the essentials, using 3D spatial awareness to decide what's truly important. This keeps the system efficient, even for long navigation tasks. But how did researchers test if this works? They ran experiments called ablation studies. Essentially, they tweaked parts of the system to see what matters. For example, they tested how different types of actions, like moving forward, turning, or stopping, affect performance. The results? StreamVLN outperformed other methods, especially when it came to zero-shot generalization, which means it can handle new, unseen environments without extra training. Here's the kicker. StreamVLN doesn't need specific training for tasks like finding a particular object. Imagine teaching a robot to navigate a kitchen without ever showing it a fridge. That's what this system does. In tests on the HM3D dataset, it beat models that relied on explicit object-specific training. How? By learning to reason about space and instructions, not just memorize steps. But here's where it gets even smarter. Navigating real-world spaces generates a ton of data, like thousands of camera frames per second. To keep things efficient, StreamVLN uses a technique called voxel-based pruning. Think of it like a memory filter. It removes redundant visual information, retaining only the 3D spatial structure of the environment. This allows the AI to focus on meaningful landmarks, like doorways or furniture, while discarding irrelevant background noise. Ever wondered how a robot could follow a sentence like, turn left at the green plant, or walk past the sofa to the white dress? That's exactly what StreamVLN does, and it nails it. In real-world tests, this AI system acts like a super-smart navigator, blending sight, language, and smarts to move through spaces like a human would. Here's the cool part, it's not just guessing. StreamVLN uses cameras to see its environment, natural language processing to understand instructions, and clever data handling to remember where it's been. Imagine it's solving a puzzle, like spotting a painting in a room and using clues from its description to find the exact spot. In simulations, it's conquered maze-like offices, sprawling parks, and even tricky indoor layouts. This isn't just about moving, it's about comprehending the world. By stitching together visual clues, language, and spatial awareness, StreamVLN shows how AI can go beyond rigid code to interact with our messy, beautiful reality. The next time a robot guides you or a navigation app gives directions, remember, this is the future. A future where machines don't just follow orders, they get them. Thanks for exploring this with me. Science like this is what makes tech feel alive. Keep wondering, keep asking questions, and stay tuned for more deep dives into the mind-blowing world of AI. See you next time.